Alright, I just want to talk a little bit about Shiny, our Shiny for building web applications. So we're on the second part here. And so this allows you to develop interactive web applications using R and using R analysis behind the scenes. And I'm going to show you a few little Shiny apps that I've made that use Leaflet. So they use something that we were working on in the last class. And I have posted the R Shiny cheat sheet because it's one of the more popular packages in R, so of course there's a cheat sheet for it. And I guess it's rendering here sideways. That's kind of annoying. There we go. I just downloaded it and fixed it. And so the Shiny application is basically a web page. It's a way of R to map to HTML. So you can see down here, there's CSS and HTML behind the scenes, as well as some. Essentially, a R Shiny app is made up of two things. There's the UI object, or the user interface, which is nested R functions that assemble an HTML user interface. And so that's going to be all of the HTML tags that you're familiar with, all of the widgets that you're familiar with in a interacting with in a web page. So you can have checkboxes, you can have date inputs, file uploads, radio buttons. So it's basically the UI is just a mapping of R to the HTML tags or the document object model. And then the second part of the Shiny app is the server. And this is going to involve the functions that have instructions on how to react to the elements in the UI, in the user interface. And so you'll see in a minute when we pull up some examples, the server is just this weird function that wraps around some R code, so you can just put in your R code, your R analysis, and the server reacts to changes or things that occur, objects in the user interface. And then those are the two parts combined. They make this Shiny app, which you can run, and an HTML page will open with these interactive features. And so basically this whole application is made up of inputs and outputs. So there's inputs arranged on the right here, the different types of inputs in the user interface, and then the types of outputs that can be rendered in interactive panels. And so just to sum it up again, the UI component is going to be the input spot, or where you're going to put like all of this stuff like sliders or buttons or things that you want the user to interact with. And then the server is the part of the Shiny app that is a set of instructions that uses the input provided by the user from the UI, processes them with R code, and produces an output that is going to be further displayed, some sort of interactive display in the output. And so in this case, the output we're going to be aiming for is one of the Leaflet interactive maps that will take information from the user about what needs to be mapped. Okay, so that cheat sheet is just under the week 8 module. I also have a Shiny user interface layout guide, and you'll see what this looks like when we look at the example in a second, but it's just sort of showing what the layout of a page is. Similar to HTML, you're going to have your headers, your titles, you might have a side panel or a panel on the bottom, a plot output or the interactive output panel. Let's see if there's some different ones. Here's some other examples of how they can be arranged within the app. You can have different tab sets. Again, this is all stuff that can be done with HTML as well. It's just showing that Shiny provides a mapping to that document object model format in the browser. So I just put this up there if you were looking for extra guidance, if you were interested in getting into making these interactive applications. And I'll also show you a few, just some examples here. So here's our Class 7 examples where we were working with Leaflet and stuff like that. And if I wanted to make a Shiny application and put my R script in it, I would just go to file, and just like you make in our Markdown document, you might have noticed that underneath our Markdown option, there's the Shiny web app as well. Similar to Knitter, I don't think you need to install Shiny, the actual library. I may be wrong. It may prompt you to install it, but I think it's built into our studio here. So when you click Shiny app, it's going to pop up with your application name, and I'm just going to do a test here, and where it's stored, like let's just do in our class here. Okay, and then create, and then it opens up a template similar to our Markdown. It's opening up a template Shiny app, and you're going to recognize these components right away. Here's the UI piece of it that I was just talking about, where it creates a fluid page that's going to have the inputs and interactive outputs. It has some example data in there, much like with the R Markdown. It generates an example of the cars data set, I believe, just to show you how the layout of R Markdown works. This does this old faithful geyser data, I suppose. And then it's setting up those panels. There's the sidebar layout, the sidebar panel, and then what the inputs should be. So these are going to be the widgets or UI interface. And in this case, they have a slider. And so in the place of that, here's where slider input is, but any of these other inputs could go in there as well. So that's just the place where you put in the input if you want it in that panel. And so once you've put in your inputs, still within the user interface, within the main panel usually, I mean, you can have it wherever you want, you're going to have what the output is specified to be, what it should look like in the interface. And in this case, it's calling the name of something that was actually given. That name actually gets assigned in the server. And so below this, below the user interface setup is the server. And like I said before, the server is just like a funky little function that reacts to things in the user interface. So in this case, the output, which is what you specify as the type of object that you want Shiny to be working with, is right here, but you can then specify the name of the output, basically whatever that variable is named. In R, in this case, it's distplot. And then you use this render function, some sort of render, and there's different ones for different things that you want to render as the output in the user interface. So you can see there's a bunch here. There's render image in the cheat sheet, render plot, which is one we're looking at, render table, which we'll see an example of, and I don't know if you see it on here, but there is a render leaflet, so we'll see that as well. And so this is all within the output, is just the actual code that you want to do the analysis and plot the output. And so in this case, it's doing a histogram and with that geyser data. And then the last thing you'll see is the function that calls the Shiny app to run it. And it's going to combine the UI and the server together. So if we just run the app, I think it's going to want us to save it. We don't need to save that. Okay. So we're just going to run this example app. And this is that slider UI object. And so you can slide it, and it's going to interact with the server and change the code. And the code that's within the server is going to respond to that and produce an output. So those are how those two things work together. So if I'm changing the number of bins, you can see the number of bins in the histogram are changing. So it is interacting with the web page to produce some interactive result. In this case, it's a plot. And I should say that R doesn't really have a sense of event handling like you learned in JavaScript. It is using what we call reactivity. It's reacting to changes, but at some point behind the scenes, JavaScript, when you're working with anything that's being delivered on the web, JavaScript's interacting at some point to tell it what has actually changed. And then R is going to pick that up and be like, and change the actual results of the output. So JavaScript is acting as a go-between somewhere behind the scenes here, but the actual analysis and this histogram and everything like that is powered by R. So it's a pretty cool way to deliver interactive content with your data in R and to R users. So I'm just going to go to an example that I did recently here. Let's see. So if you remember, we were working on mapping some of those weevil species with information from the Global Biodiversity Index, and we were mapping them in Leaflet. And so I've created a Shiny app here. See, it's calling in a lot of those libraries that we used, all of the libraries that we used to do that, because I'm going to use them here. So much like our Markdown, you still need to call in your libraries that you use in the Shiny app at the beginning here. And then I'm setting up my user interface. I still have a title panel, a sidebar panel, but instead of the slider input that you saw before, I actually am doing a file input. So this is going to be, it's going to be the similar interface to what you've seen with HTML when it asks the user to upload a file. It will ask you to browse your computer and upload the file, and then I also have specified that I want it to say choose CSV file, because you can make the input only accept certain types of files. So in this case, I am directing it to accept text formatted CSV, comma separated values. There's also a header tag in the UI interface for checking if your CSV file has headers or not. And then for the outputs of whatever code is executed by the server in the main panel, I'm going to do a table output. So I'm going to display that CSV file, whatever is in there, as a table to the user. And then I'm going to do a leaflet output. So leaflet's specified as an output that our Shiny recognizes. And these are just the names I've given to those variables that will get outputted. So basically, locs is going to be defined in the server as the location coordinates for whatever lat long data gets put in by the user. It's a little bit backwards to have the output up here in the UI, but it's just how the UI and the server have to react to each other. So typically this part would be blank. I don't know exactly what I'm going to name my outputs yet, and then when I finish it down in the server, I'll put in the names of those outputs of the resulting map or whatever within the leaflet output, if that makes sense. And then the server function, the second part, is going to take the inputs of the UI, do something with them, and render the outputs. So I have this reactive function in here as well, and this is basically a function that is going to be waiting for the user to do something. And in this case, it's going to be waiting on the user. When you run the app, it's going to be waiting on the user to input their file. So like I said, it has to do with our Shiny works with reactivity, and this is one example of a function that's kind of waiting and listening for that file input to change, to update. And again, somewhere behind the scenes, JavaScript is actually letting it know when that update occurs, but essentially that's what it's doing. And then I have specified the input as just file1, and there's also a if statement that if that file is null, if nothing has been put in there, it's just returned as null. And then I'm also going to use read.csv, because in here we're just typing in straight R inside the scope. It just takes, it just executes R, and it's going to read that in file input. It's going to read the data path and the headers, and then it returns locs. And so locs is just going to be the locations or the lat long data that's in that user input file. And then as one of the outputs specified here, we have the table output, because I want to show that user file as the table first so they can see if there's any issues with it or anything like that. And so that's going to be a render table function. So that's what's going to show up in the outputs, and all of this is assigned to my data. So we should see up here in the output panel, in the main panel, the table output is table.output, which is what I've named the output right here. So inside that is a function that's going to render the table and show my data, which is this whole chunk right here. And I'll be posting this example online, by the way, so you don't have to be reading it super quickly or following along, because you can pick it up on the GitHub later. And then the second output, you can define multiple outputs. I can have different plots, tables, maps. You can have as many outputs as you want in the Shiny function. I'm doing a different output, and I'm going to call it Lokes, because again, up here in the user interface, that leaflet output takes the name Lokes, so this is where that gets defined. And it's inside there is going to be the render leaflet function. And so then within the scope of this function, within the curly braces, I'm going to assign that my data that's picking up the data from the user's user inputted file to Lokes locations. And then this is the same bit of code that we had in our example from set from class 7, where I am assigning the coordinates of Lokes to the longitude and latitude columns within the documents within my data. And then I am creating a leaflet map to map that species here. And I'm assigning it to Lokes, which is going to be the name of the output in the leaflet output part of the user interface. And then again, at the end, it just calls the Shiny app. And so if we run this one, sure, I'll save that. So the first thing that you notice here is it's waiting for the user to do something. And I've left this error here because remember that there was an if statement that said if there's no file in there, it equals null. Well, in this case, this down here is where the plot is going to render. So the server was basically took that null and said it can't do anything with that. So it is waiting and listening, and it knows that there's nothing in here right now. And so that is going to, with that reactivity, that is going to update when we put in the file. And I'm sure there's a way that we can get rid of this error and stuff, which I'll probably figure out in a bit, but it just sort of demonstrates how the user interface and the server are interacting for now. So I'm going to browse on my computer. This is just like any web document, and let's see. I'm going to navigate to the locations of my other weevils, Pseudorhynchus scribicalis. So last time we did Constrictus, and I'm just going to get a location CSV that I have on my laptop. And there are fewer points for Pseudorhynchus scribicalis, but as you saw, it uploaded the file. And then once that happened, all of those outputs that were defined in the server, this main panel with the table output and the leaflet output, they were able to go to the server function and execute. So we were able to see the output of the table that displays the data that was put in by the user, and then the map was generated as well. So here's the latitude and longitude. It's displaying the headers because that's checked. If I uncheck it, it just assigns random names to the headers. And then here's the map. Here's the leaflet map. Let me zoom in a bit. So it's totally zoomable and an interactive component of the main panel. So that's just an example I have of one of the Shiny apps that's related to the stuff we were working on in class 7, and I can upload that Shiny app so you can download yourself and take a look. I know I went through the Shiny applications really quickly. There's a lot of tutorials out there online to look at, and frankly I'm still learning a lot about Shiny myself. That was just sort of like a brief version of what I know about it. But I do also want to point out that just the syntax of Shiny is kind of annoying with all of these parentheses, and you always have to have commas between the elements of the user interface. and as well as the elements of like the outputs as well. So you can see there's a comma here in between outputs. There's commas in between, you know, each of the inputs. And if you leave one of those out, it will throw an error that says you're missing a comma. But it's one of the things that annoys people the most about the Shiny syntax. And I'll just show you one more Shiny app that I was working on, again, for the class I was taking at the U of M. This is the same class that had the baby names assignment that I was showing you earlier, where I used per. And by the way, that class is called, hang on, Public Health 7462. It's in the School of Public Health at the University of Minnesota. And it's Advanced Programming and Analysis in R. And I just wanted to point it out in case people were interested in taking the R class. It's only 2 credits, so it's not super expensive, but still, you know, credits at the U are kind of expensive. But if you're interested in that class, just let me know, and I can direct you to it. But this was just another assignment that I did earlier in the semester with a Shiny app, and it uses Leaflet again. And we were supposed to be getting this data from the Center for Disease Control that has geolocation information on the types of health risks that are present at different census tracts of different cities. It's called the 500 Cities data set. And so I'll just run this quick just to show you, because it has some different inputs, but it's still doing the same output of the a leaflet map. So here's what it looks like. Instead of the file inputs, we have a drop-down menu where you can choose the cities. This was from the 500 Cities CSV that I downloaded. So it's just referring to that column. And so like, let's just select, you know, Anchorage, Alaska. And the health indicator that it has is just current lack of health insurance, but there's a lot of different ones in here. Taking medicine for high blood pressure is one. And then when you scroll down, you can see the risk factor. So that's the percentage of the population that has this condition mapped. So it's mapped by color, and also it's supposed to be mapped by size as well. So let me just change that. Yeah, so then the size changes. Let's do a different city maybe. Let's do St. Paul. You know, St. Paul, there's St. Paul. We'll do visits doctor for routine checkup, current smoking among adults. So yes, so these are just some more examples of the different inputs that you can have. And again, these inputs are just referring to columns in the data frame of the 500 Cities data set. So just to point that out. Yeah, so GeoClean is what I called that data frame, and it's just referring to the city name file for the first select input, and then you can put in another select input, of course, with that comma in between, and in this case it was referring to the measure of health for those different health risk factors. So that's just an example of another app using Leaflet. And I just wanted to point out the Shiny applications because it is it's nice and baked into RStudio. And so at some point, if you continue working with R in RStudio, you're probably going to notice Shiny and become interested in using it because it's a very nice way to display your data to the users in an interactive way. But that's pretty much all I wanted to talk about with Shiny. I also have posted the showmeshiny.com gallery of Shiny projects. That's really fun to look at, just so you can get ideas. They have different examples in here, and you can get the code as well, which is pretty cool. So, you know, I'll just click on one as an example. Yeah, so you can get the code for these different Shiny applications. You can look at the documentation. So it's a really nice gallery. And you can, of course, preview the Shiny app and play around with it. So that's all I have for the Shiny apps. Like I said, I'm still learning new things about Shiny all the time, and you'll see from the cheat sheet, it's pretty big. It's a pretty big package, but I would recommend, if you're interested, looking at some YouTube tutorials, and of course Stack Overflow and blog posts have been really helpful for me.